Hey Pre-Calc Pros, I'm going to be taking a look at the P5 homework that you had to complete for Tuesday the 24th. I'm going to skip some of these because I did them in class, so if you need those, you should have been copying them down when we did them. I'm going to start first with 11, which was x being cubed, and we were deducting 2x squared. We were then adding on 5x and then subtracting 10. With factoring by grouping, recall that we focus on the first two terms, take out a greatest common factor, which in this case is going to have to be x squared. And then we think out what times x squared would get you x cubed, which is definitely x. Then we want to deduct that too. And if we did everything correctly, we know that x minus 2 should also be appearing over here again. And so now we have to ask ourselves, what times x would get us positive 5x? It's pretty easy to say it's going to be positive 5. So based off of this, we take our two greatest common factors, seen here, we make a new binomial with those, call it x squared plus 5, also include x minus 2, and we're done. This is the factored format for 11, seen here. $15 adds a little bit more to it now with the numbers thrown into the mix. So we have 3x cubed minus 2x squared minus 6x plus 4. First two terms, I know I can take out x squared. I can also take 3x minus 2 and leave that. I know 3x minus 2 should be left over here. And so now I'm thinking, what times positive 3x gives us negative 6x, which in this case is going to be negative 2. So our final answer here is x squared minus 2 with 3x minus 2. Final answer. 17 and on is where we start to see diamond method. So for this, I'm just going to include the diamond. I'm not going to write out the original problem because you should have that on hand, and you should be always writing the diamond if you get stuck. So I know that this is just basic factoring when the a coefficient is 1, so note that. 17, I should have 6 here, 5 here. I should have the factors of 2 and 3. So our final answer is x plus 2, x plus 3. For 18, you should get negative 15. You should also be getting negative 2. Negative 5 plus 3 is going to take you there. X minus 5, x plus 3 is your answer. And remember, you can always check your work on this if you FOIL out, which we saw in P4. 19's pretty, so this was 19. How about this? I'm going to do the odds. So let's keep this going. We'll do 21, and that should be positive 15. But now with negative 8. So I know it's a positive product, but a negative sum, so these are both going to have to be negative. Make one negative 5, make one negative 3. Notice the difference in comparison to problem 19. And again, since it's multiplication, the order that you write it out doesn't matter too much. With 23, recall that our a coefficient is no longer 1, and this is for the 3x squared minus x minus 2. So our diamond should look like this with negative 6, negative 1. We should be subtracting 3, but then adding on 2. So we get something like 3x squared minus 3x plus 2x minus 2. We can factor out 3x here. X minus 1. X minus 1 should also be here. Positive 2 should be here. Final answer is 3x plus 2, x minus 1. 25, staying alive. We have a little bit more to go for us here because we have to multiply 3 times that 28, which is going to give us 84, I believe. Yeah, negative 84 for 25. and our speed coefficient's negative 25. So we have to be a little strategic here. I know one of these is going to be negative, the other is going to be positive, and I know that factors of 84, you could do 2 and 42. You could also do 3 and 28, which looks pretty close. So if we do that, we know that we're going to be having a negative 28, positive 3. Eventually, you know, you can rewrite it like this: 3x squared plus 3x minus 28x minus 25, or sorry, minus the original, which was negative 28. Factor out 3x, leave x plus 1. Negative 28 should be in there. If we take this further, final answer is here. 25, staying alive. And I'll also take a look at 27, where the diamond will look like this. We have 24 in our denominator, or the bottom part, sorry, not a fraction. We have negative 11 here. This should be negative 8 and positive, or sorry, negative 8, negative 3. Be careful there. So if we rewrite 6x squared minus 3x minus 8x plus 24, 3x we can take out. We can leave 2x minus 1, leave 2x. Oh, sorry, instead of 24, this should just be 4. My bad. So also leave 2x minus 1. This is going to have to be negative 4. So 3x minus 4, parentheses 2x minus 1. And then we start to hit the real world situations, or the ones that are a little bit more complex. So first I'll show what the problem looks like, and then I'll show the work on there. All right, so for 117 and all the way up to 119, our situations look like this. We're being asked to write an expression for the area of the shaded region, and then also write the expression in factored form. So we have two areas that we need to focus on. So I'll start first with the area of the shaded region. So for problems like this, you can break it down as much as you need to. I know that we have the larger square here, which is pretty easy to take hold of because it's a square of 3x times 3x. So in this case, the square itself, so all of this is 3x multiplying with 3x. It seems kind of weird to rewrite it in an algebraic variable type of expression, but it's totally okay. So this is 9x squared. And then if we look closely, we have how many smaller squares here that are white? So you should be saying 4. So it's as if we want to take the whole square and then we want to deduct the 4 smaller squares. So it's as if we have 9x squared and we want to deduct 4 versions for the area of the smaller square, which is 2 by 2. So we can call these the 2 by 2. So really this is 9x squared minus 4 times 4, which can be rewritten to 9x squared minus 16. So this would be considered the shaded area. And then if we wanted to factor this, because that's what they ask in part B, we know that 9 and 16 are perfect squares. So this is similar to in the video, the very last problem, we factored a perfect square, or difference of squares, pardon me. I forget which one it was. But I know that the factor of 9 is 3, or square root of 9 is 3. Factor of 16 is 4. Since there's no middle term, I want to make one negative, one positive, and then I'm done. So notice what I did here. I looked at the larger picture. I said, what's the square, the larger one? That was 3x times 3x. And then I wanted to get rid of the white squares because those were not shaded. And this was again 117. And we'll look at 118. So for 118, same kind of song and dance. We have 7x times 7x. That's the area of the larger square. And then we want to deduct 4 versions of that smaller square. So it's as if we have 49x squared, then we're subtracting 4 times 9, which is 36. Also a difference of squares, so 7x minus 6, 7x plus 6. There it goes. So this would be the shaded region, this would be the factored form. We're done. Finally concluding with 119, a little bit more complex, but nothing we can't handle. So we have the larger rectangle here, which is going to be x multiplying with x plus y. But then we want to deduct this bit in the middle. So this is a little tricky to express. So this gives us the full rectangle, but then we want to deduct that smaller portion in the middle, which is a little tricky to express, but we could say that this is all of x, but we just want to get rid of y. So we're actually allowed to just say that this can be rewritten as x minus y, because think, you have all of x, and if you deduct y, or actually, my apologies, something different. All right, so the y bit here is actually the base is y, and then the height is x plus y. So you could call this y, and then x plus y, and that will get rid of the middle. My apologies for that. So if you distribute in x, this gets you x squared plus xy. You're also deducting yx, and then y squared. So this eventually will cancel out your middle term, and this just leaves you with x squared plus y squared. And this is your answer. And you actually can't factor it. Actually, no, you can. Yeah, sorry, because you're subtracting all of this. So subtract this. Now you have a difference of squares, x plus y, x minus y, done. There you go, my bad. That was 119. I hope this was helpful. If you have any questions on the problems that weren't covered, let me know. Shoot me an email, ask in class, do what you need to do to be successful. Thanks for watching.